Hello and welcome to another Algebra 1 video by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 3, Lesson 5 on key features of graphs of functions. So functions can oftentimes be represented by graphs. And when we represent a function using a graph, oftentimes there are features that we want to be able to talk about, we want to be able to discuss, and we want to know the terminology of. So what we're going to be doing is getting into a lot of those today, and then we'll be using them throughout this course as we examine different types of functions. So let's begin and learn about some of the major features of functions. Now, graphs of functions have many important features. Keep in mind though, something very important. When we talk about the value of a function, we are always referring to the value of its output or y value. If we're talking about the input value, that'll be very clear. But if I say something like, what is the largest value of the function? What's the smallest value of the function? You should be translating that into the y value or the output. So let's begin by taking a look at exercise number 1. The function y equals f of x is shown graph below. Answer the following questions. Letter A, find the minimum and maximum values of the function. State the values of x where they occur as well. All right, so in other words, when you see something that looks like this, minimum and maximum values of the function, right, we want to think of that as the y values. Okay? Now, it's pretty simple, right? The minimum is simply the lowest y value on the graph. And I can see that very clearly on any graph, right? I can just look here and go, well, that's the lowest y value. It occurs right here. That's at the point 2, -6. So the minimum value is -6 and it occurs at x equals 2. Now that minimum value of -6 could have occurred at multiple x values, but at least on our graph it only occurred at that one. Why don't you pause the video now and figure out what the maximum value of our function is and the x value where it occurs. Right? Well, the highest value, the greatest y value on our function occurs right here, right? That's at the point -5, 8. And so the maximum value of our function is 8, occurring at x equals -5. All right, the next question is one that you should be familiar with from equations of lines. Let's talk about letter B. What is the y-intercept of the function? And follow up, what is the x value at any function's y-intercept? All right, so the y-intercept of a function is simply the y value where the function crosses the y-axis. The y value where the function crosses the y-axis. So that's right here at the point 0, -2. So the y-intercept of the function is -2. And, right, this is very important, what is the x value at any function's y-intercept? Well, the plain fact is all along the y-axis, all along this axis, the x-coordinate is 0. So almost by definition, the y-intercept is the output of the function when the input is x equals 0. All right? Very important, right? X equals 0 is where the y-intercept occurs. What the y-intercept is the output, in this case, -2. Now, a related idea, all right, and maybe I'll keep this right here so we can still see the graph. Let's take a look at letter C. Circle and state the x-intercepts of the function. These are also known as the zeros of the function because they are where f of x equals 0. All right, so you've got the y-intercept, right? And every function will have at most one y-intercept, all right? You might want to think about why that is, but a function could have multiple places where it crosses the x-axis. And in fact, this function has an x-intercept there and an x-intercept there, and they occur at x equals -1 and x is equal to 8. This term is very important, the zeros of a function, right? So the zeros of a function are the input values where the output is equal to 0, all right? And it's true, right? At this point, right, that's the point -1 comma 0. This is the point 8 comma 0, right? So the zeros of a function are the x values where the y value is 0. The y-intercept is the y value where the x value is 0. So similar ideas, but a little bit different because of the differences between inputs and outputs. All right, let's take a look at increasing, decreasing, letter D. Would you characterize the function as increasing or decreasing over the interval -5 is less than x, which is less than 2? Explain your choice. Okay, so again, let's make sure that we just understand this domain interval, right? Basically just saying as x goes from -5 to 2, is the function increasing or decreasing? So from here to here, from this point to this point. Well, what do you think? Pause the video and write down whether you think that the function is increasing or decreasing over that interval. Well, some of you might very logically say, well, it depends on how you look at it. If you go from this point to this point, right, you're going downhill, so the function is decreasing. But if you go from this point to this point, you're going uphill, so the function is increasing. But the correct answer, since it can be only one, is that the function is decreasing. All right? And the reason for that is very simple. What we're really asking when we ask whether a function is increasing or decreasing is we're really saying, as the input increases, what is the function doing? So as the input goes from -5 to 2, what is the function doing? What are the outputs doing? In other words, we always want to read a graph from left to right. Okay? So as x goes from -5 to +2, the y values are going down, and therefore the function, which is the y values, it is the outputs, are decreasing. Let's look at letter E. Give one interval over which the function is increasing. Use any appropriate notation. All right, well, there's a lot of intervals, maybe even an infinite number of intervals over which the function is increasing. Why don't you give one of them? All right, well, honestly, if you give any interval that's sort of in here or in here, right, then you're going to be fine, all right? In other words, the function is increasing in here, then it's decreasing in here, and then it's increasing in here. So for example, I could say, let's say I go from -8 is less than x is less than -5. That would be this interval, right? Or I could go from 2 is less than x is less than 9. Generally, I'm only using those less than symbols as opposed to the less than or equal to symbols because a lot of people are a little bit uncomfortable with including those points, right, where the function changes from increasing to decreasing or vice versa. They're a little bit hesitant to include those in the intervals, and I can totally respect that. But you could also use some smaller interval within here, right? You could say, well, how about the interval that goes from 4 to 7, right? That interval is increasing, right? It's maybe not as big of an interval, but that's okay. That would work, right? The only thing you can't do is include any x values that go from -5 to 2. Any of those x values from -5 to 2, during those, the function is decreasing. Okay? Let's keep going. Letter F. State the coordinates of all turning points on this function and label them as either a maximum or a minimum. All right. Turning points are one of the most descriptive terms for functions, and I bet if I just leave it as that, you can tell me what the coordinates of the turning points are. There's two of them. Pause the video now and write them down if you think you know them. Well, turning points are literally those places where a function changes from increasing to decreasing or from decreasing to increasing. But they are very obvious when you see them on a graph. So for instance, that's a turning point and that's a turning point. That one turning point is at -5, 8. And the second turning point I circled was at 2, -6. The one that's at -5, 8 is what we call a maximum. It's at the top of a hill, right? And the one at 2, -6 is a minimum. It's at the bottom of a hill. And those, I think most students feel very comfortable with because one, they're very obvious, right? That one's at the top of a hill, and it's kind of like if you were going up the hill, that's where you'd change directions and go down the hill. And then this one's at the bottom of the hill, that's where you would change directions and start to go up the hill. All right, now one last one. This one can be quite tricky for kids. Letter G. Give the interval over which the function is negative, i.e. f of x is less than 0. Okay, so I'm going to just kind of erase these two turning points so that they don't get confusing. Right, the function is negative. F of x is less than 0. Now, when I say this or this and they're equivalent, what I'm saying is really for what x values are the y values negative. Now, I mean, just think about it for a minute, right? Like if I picked a random point on this graph, like right here, let's say, right? That point on the graph has coordinates -3, +4. So at that point, the output, the function, is +4. So that's not part of the interval, right? On the other hand, let's say I picked this point right here, right? That's the point 3, -5. Well, there, the function has a value of -5. So that should be part of the interval where the function is negative. What I want you to do is try to write down a domain interval. You could use either interval notation or you could use set builder notation to describe all the x values where the y value is negative. Do that now. Well, visually, this is actually quite easy because I'm just looking for all the x values where the graph is below the x-axis, right? This is really below the x-axis. Below the x-axis, the y values are negative. Where does that occur? That occurs all in here, and it really starts at -1 and ends at 8. So I'm going to say -1 to 8, and I'm going to use interval notation. By the way, a little confusing because that might look like a coordinate point. It certainly isn't, all right? Now, why do I not include the -1 and the 8? Take a moment to think about that. Okay, well, the real key is, what are the coordinate points at -1 and 8, right? At -1, we have the point -1, 0, and at 8, we have the point 8, 0. Well, the question is the function negative there? Well, the function, again, is the y values. The y values at -1 and at x equals 8 are 0, and 0 is neither negative nor positive, okay? So I can say, right, that the function is negative from -1 to 8. I could also write it like this, right? Either one of those would be a completely acceptable way of talking about where this function is negative, or another way to look at it, where this function is below the x-axis. Okay, that was a lengthy problem. let's do some more. It's important to become fluent with the terminology of functions and their features. I want to be able to just give you a graph of a function or even some tables, things like that, and say, what's the y-intercept? What are the zeros? What are the turning points? Things like that. So let's look at another function represented graphically. Exercise number 2. For the function g of x shown in the graph below, answer the following questions. Letter A, find the value of g of 1 minus g of negative 1. Show your work. All right, well, you did this a little bit in the last lesson, so I'd like you to pause the video now and see if you can figure out what the answer to this calculation is. This has a little bit less to do with function features than just sort of evaluating a function using its graph. So pause the video now and see what you can do. Well, in order to find this difference, I need to first figure out what g of 1 is and what g of negative 1 is. So first, let me do that, all right? So g of 1. How do I figure out g of 1? Well, I say the input is equal to 1. The output, on the other hand, must be equal to 6, right? That's the y value. Negative 1, right, is here, and its output is equal to 2. G of negative 1 is equal to 2. So g of 1 minus g of negative 1, negative 1 is equal to 6 minus 2, and that's equal to 4, right? Telling us, of course, right, you can even see this on the graph, that the function has increased by 4 units as it goes from negative 1 to 1. Okay, letter B. State the y-intercept of the function. This tends to be pretty easy for students. Why don't you pause the video and state the y-intercept. All right, the y-intercept of any function is the y value where the function crosses the y-axis, right? So the y-intercept is right here, which ironically also happens to be an answer of 4. That has absolutely nothing to do with the fact that letter A is also 4. All right, let's take a look at letter C. State all zeros of the function. This might be the trickiest problem in terms of just remembering the piece of terminology. The zeros of a function are the x values where y is equal to 0, and those are here and here, and they happen to be at x equals negative 2 and x equals 6, right? But again, it's that piece of terminology, the zeros of a function, the x values where the y value is 0. Come on, board, there we go. Letter D. State the interval over which g of x is greater than 0. All right, so this is very, very similar to what we had in the last problem, except in that problem, we were looking for the interval over which the function was less than 0. See if you can state the interval over which the function is greater than 0. All right, anytime you see the function itself, g of x is greater than 0, you could really replace that by y is greater than 0, which for us means above the x-axis. So you can literally see it, right? It's this portion of the graph here, right? And that starts at negative 2 and it ends at 6. So x is greater than negative 2 and less than 6, or if you like your interval notation, negative 2 to 6. Right? Either one of those is fine. You don't have to have them both. I just want to illustrate that you could use either one. All right, and one last piece, the whole increasing versus decreasing part. Letter E. Give one interval over which the function is increasing and one interval over which the function is decreasing. All right, pause the video now and see if you can give those intervals. All right, well, there are many, many correct choices. All right, the plain fact is the function is increasing in here and it's decreasing in here. So as long as your increasing interval occurs somewhere from negative 3 to 2, you're good. In fact, I'm going to put the whole interval there. X is greater than -3 while being less than 2. And the decreasing interval, I'm going to say x is greater than 2 and less than 8. Now again, you could give other intervals. What you just have to make sure is you don't have an interval that kind of breaches the turning point. So you don't have an interval that like goes from here to here, because that would include both increasing portions and decreasing portions. Okay, let's take a look at one last problem. A very good way to practice learning features of functions is to create a function if you know a bunch of its features, all right? So this is really cool in exercise 3. Let's see how this is done. There we go, that's a little better. Let's take a look. Build a function h of x that has the following features. H of -9 is 3, and h of 9 is 5. There are zeros at x equals -7, -2, 4, and 8. There are turning points at -4, -9, 2, 6, and 6, -2, and finally a y-intercept of 5. All right, that's a lot of information. I'd like you to pause the video and see if you can draw a function that fits all of this information on it. Pause the video now. Now, your function is not likely to look identical to mine, and that's fine. Let's kind of walk through it. The first piece of information that I'm told, h of -9 equals 3, and h of 9 is equal to 5, really just tells me 2 points that lie on the function, -9, 3, and 9, 5. So I'm just going to plot those, right? Here's -9, 3, and here's +9, 5. The second piece of information about the zeros tell me where the function crosses the x-axis. The function is going to cross the x-axis at -7, 0, -2, 0, 4, 0, and 8, 0. All right, the function is going to turn or change directions at -4, -9, 2, 6, and 6, -2. And finally, the function is going to have a y-intercept at 5. Right? So no matter what, you've got to have those points marked. All right, those points have to be marked. And now you just have to kind of connect them with some kind of curve, right? You could connect them kind of all with straight line segments, like you could just be like doop, 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 boop, 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 boop. Or you could make it a little more curvy, that's fine. But at the end of the day, it essentially has to look like that. Again, you could have more of a gentle kind of curve going on, or you could just have straight line segments between every one of the points. But you gotta have something that looks kind of like that. Let's take a look at one last problem, exercise number 4. Give one interval on your graph for which the function is negative. All right, pause the video now and see if you can write down one interval where the function is negative. All right, well, based on the description of the function, there's actually 2 intervals over which it must be negative. And remember, the function being negative means that the y values are negative, so you've got some of those here, right, where these y values are negative, and then you've got some negative y values in here, all right? So one interval where the function is negative simply would go from here to here, and that's from -7 less than x less than -2, or from here to here, which would be -4 is less than x, which is less than 8. All right, and notice how those intervals are really all about where the zeros are, right? Because the zeros are where the function crosses or intersects the x-axis, right? That must also be where the function changes from being above the x-axis to below the x-axis, right? And you can see, right, one of our intervals where the function is negative is between -7 and -2. The other one is from 4 to 8. I don't know why I said -4. That's a little bit weird. That's not -4. That's a +4. -4 would be odd. It's like way over here. All right, but that's it, right? Wherever that function is below the x-axis is where the function is negative. All right, let's wrap this thing up. We saw a lot of terminology today, and it's terminology we're going to be using a bunch in the future. And what were the major pieces we saw? We saw y-intercepts. We saw x-intercepts, which are also called the zeros of the function. Very important piece of terminology there. Right? We saw intervals where the function was increasing, going uphill, and intervals where the function was decreasing, going downhill. We saw intervals where the function was positive above the x-axis, and intervals where the function was negative below the x-axis. And we also saw these things called turning points, and those were points on the graph where the function changed from increasing to decreasing or decreasing to increasing. We're going to see all this terminology as we go forward and explore various types of functions, and we'll also notice how some functions have some of the features and other functions don't. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.